Brad Williams, Frugal Finance. We're going to crunch the numbers for the SOFR, options on SOFR. This is going to be similar to European bond options. There's going to be clearly a few modifications, but in short, the format's going to be similar. So let me explain what we're doing and show you the numbers. We're going to crunch a lot of numbers here, or you're going to crunch a lot of numbers. I've already crunched them. And then we're going to wrap it up with a summary. So the black model applies quite directly to calls and puts on SOFR. The currently observed forward SOFR, or forward SOFR, plays the role of the futures price. Specifically, forward SOFR is observed at time t when the option is being valued. It is forward SOFR with a maturity corresponding to the maturity of the option, and it is the forward rate with a time horizon that matches the expiration date of the option. Got that? Maturity and dates need to match up. Well, notice that the forward SOFR should be identical to the forward rates for the same period in the future. Remember the law of one price? It should match all hypotheticals, okay? So here we're looking at forwards, futures, and what have you. Using SOFR in the black model is tantamount to assuming that the forward SOFR is log normally distributed. The strike rate plays the role of the exercise price, while the standard deviation of the SOFR forward rate of the requisite maturity is the volatility measure of the model. Got that? The strike rate plays the role of the exercise price, and the standard deviation is the volatility measure for the model. Here's the call, here's the put, here's DISA 1, DISA 2. Similar to what we've practiced in the past, but as always, that volatility is going to take a little bit of work to crunch. In this equation, we have the black model with the following substitution. Forward SOFR takes the role of the future price, and the strike substitutes for the exercise price. The payoff on each option is discounted for a longer period. The time to expiration plus FRAC will account for the delayed payment. Remember, we're saying that there's that 3-month delay, and the values of each option are multiplied by NP of FRAC to convert the values to dollar amounts. And that's notional principal times FRAC. The following equation is identical to equation 1912, except that it uses a zero coupon factor instead of the continuously compounded rate to discount the payoff on the options from the payoff date. The expiration of the option plus FRAC. To present this number here, break out the magnifying glass if you need to, because you can see the notation, a little bit of changes. We got this forward SOFR, which is going to be a little bit different from the previous example. And then keep in mind, we have that exercise price and strike price have been identified as a different part of the ingredient. DISA 1, DISA 2, just walk through, plug and chug. There's no reason to spend a lot of time unless you want to break this stuff down and identify different parts of the formula. Applying the black model to the option on SOFR. As an example, consider a call and put a 1-month SOFR that both expire in 8 months. So we have a 1-month SOFR expiring in 8 months. The strike rate on the call and put is 7%. The notional principal is 10 million. From the FRA market, the historical standard deviation of the 1-month SOFR has been 0.23, which is our estimate of the standard deviation of SOFR. So we're taking a bit of a shortcut. We're not calculating the standard deviation. We're going to use some historical data, good or bad. You will, with experience, you'll determine if you need to come up with a different method. The yield curve is downward sloping, as illustrated in the last 2 columns in 19.6. You're going to open up that previous worksheet to look at that data, because I don't think I duplicated it. Nope, I didn't. You're going to go back to 19.6, which assumes monthly compounding. The 1-month forward rate for a period from month 8 to month 9 is the value we need for forward SOFR from table 1916. I pulled up 19.6, the European option pricing, the European forwards. The 1-month forward rate for a period from month 8 to month 9, right here, I think it's this number here, is the value we need for F SOFR from table 19.6. We see that the 8 and 9 month zero coupon, oh, this is downward sloping. So we have 1.052 at 159. All right, how did I get it? Well, you remember, you plug and chug. Well, here's your plug and chug. The 1 month forward rate is therefore 105.94 divided by 105.27 minus 1 is equal 0.00635. Shown right here. With monthly compounding, the annualized rate is 1 plus 0.0635. This should have a little caret, but don't worry about it. 0.7911. Here you go, right here. The 1 month maturity corresponds 1 divided by 12 using the zero coupon factor 105.94. To cover the 9 months until payment on the option would be received, the option values, according to equation 1913, are as follows. Well, we've done this. I'm not going to rehash this. You know how now, just to put in the information, substitute this European information over here on this SOFR. And you're going to come up with the DISA 1, you're going to get a DISA 2, then you have your normal distributions, DISA 1, DISA 2, then you're going to compute your call price and your put price. You can go through with magnifying glass and fine tune this information if it interests you. If you, like me, are extremely busy and you're trying to get a general overview of this information, then go through it a couple times, reread this, crunch the numbers. Don't rely on my numbers. They may be wrong. Go through and use my formulas, cut and paste. There's no reason for you to spend hours after hours putting this stuff together. Use it, but understand the logic. Because if your managing director who's been doing this for 25 years steps up and asks you a question, don't look at them as though a deer staring at headlight. Be able to respond intelligently with a foundational answer. In other words, don't bore them. Just give him the fundamental or give her the fundamental reason for the question. All right, so answer it the best you can. Brad Williams, Frugal Finance. Thanks for watching.